Welcome to this explainer. Look, if you are studying for Cambridge mathematics, you already know that sitting down in that exam hall is not a sprint. It is a grueling, multi-hour marathon. It is an absolute endurance test of your logic, your precision, and your energy management. Today, we are unpacking exactly how you can pace yourself and jump from a frustrating B grade to a definitive A star. We are going to use one of the most mechanically demanding topics as our testing ground: complex numbers, specifically focusing on the Cartesian form, X plus iy. I want to introduce you to two very typical students we see all the time. Let's call them Alex and Sam. Alex is the overloader. Alex walks into the exam, sees a complex numbers question, and just vomits raw mathematical facts onto the page. Every formula they can remember about real and imaginary parts, just scattered everywhere with zero analysis. Sam, on the other hand, is the rusher. Sam is so obsessed with the clock that they completely miss the specific command word requirements of the question. They solve for X and Y, but miss the part where the examiner asks them to evaluate or verify. Today, we're going to look at their flawed answers side by side with the red examiner marks, and we are going to fix them. Here is our exact battle plan, our agenda for today. First, we are tearing down the B to A star gap to see what examiners actually want. Second, we will lock down the core concepts of real and imaginary parts. Third, we establish our unbeatable methodology framework. Fourth, we look at the examiner warnings that trip up students like Alex and Sam. And finally, we will build the ultimate complex numbers blueprint. Stick with me, because the strategies we cover today don't just apply to one topic. They are your cheat code for the entire syllabus. Let's kick things off with Section 1, the B to A star gap. We really need to examine what separates a perfectly fine math candidate from a truly exceptional one. And honestly, it almost always comes down to decoding the assessment objectives. The difference between Alex, who is stuck at a B, and an A star student isn't necessarily raw intelligence. It's strategy. When Alex sees a complex numbers question, they just see numbers. But Cambridge examiners are looking for a highly structured analytical process. They're looking for you to break down command words. Does the question say, find, show that, evaluate, or deduce? Sam loses massive marks because they treat show that exactly the same as find. If you don't lay out your evidence and explicitly link it back to the command word, your mathematical brilliance literally does not matter. The examiner cannot give you the marks. This brings us to the holy grail of Cambridge mathematics, the method marks strategy. You have to understand that marks are awarded for your process, your logical reasoning, and your cross-topic connections. This is where we introduce the Peel framework, adapted for mathematics. Point, evidence, explanation, link. It sounds like an English essay trick, but it is devastatingly effective in math. Your point is stating your algebraic approach, like multiplying by the complex conjugate. Your evidence is the given Cartesian data. Your explanation is your flawless line-by-line execution. And your link is checking your final X and Y values against the initial constraints. If you just scribble down a final coordinate like Sam does without proving the steps, you are actively throwing away method marks. The examiner's red pen will be ruthless. Now, before we dive into how to perfectly execute this on Syllabus 9709, I need to remind you that these principles are universal. Whether you are taking IGCSE 0580, O-Level 4024, Additional Maths 0606 or 4037, Statistics 4040, or going deep into AS and A-Level 9709, the cross-topic connections are what secure the top grades. Top-performing candidates constantly link complex numbers to trigonometry and quadratic expansions. But listen up. Before we continue and reveal exactly how to decode these command words, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It is absolutely essential if you want to keep getting these high-level strategy breakdowns. All right, let's get back to it. Moving right along into Section 2, Core Concepts. We need to look closely at the real and imaginary parts of complex numbers, because this is the foundation where we will apply our Peel framework. You cannot strategize if your basic definitions are wobbly. This fundamental definition is your absolute starting point. The Cartesian form X plus iy is an architecture defined strictly by a real part, which is X, and an imaginary part, which is iy. Grasping this requires total, uncompromising precision. Remember Alex? Alex tries to solve these equations by jumbling everything together, moving the I around like it's just another algebraic variable, like A or B, and entirely losing track of the real and imaginary boundaries. You have to clearly distinguish and manipulate these two parts without muddying the waters. When you expand brackets, group your real terms.
Group your imaginary terms. If you blur the lines, the whole architecture of your answer completely collapses and you get 0 method marks.
This slide brilliantly illustrates the core issue. The Cambridge Assessment Framework explicitly prioritizes analytical depth over superficial breadth. Superficial breadth is Alex memorizing the quadratic formula but having no idea how to apply it when the discriminant is negative, resulting in a complex root. Analytical depth means understanding the exact mechanics of why X plus IY behaves the way it does. It means knowing exactly how to execute a complex division by multiplying the numerator and denominator by the conjugate of the denominator, expanding meticulously, and then, here's the crucial part, splitting the resulting fraction back into distinct real and imaginary components. Now let's do a quick 30-second mental drill. I want you to imagine a student's answer block. If they skip the step showing the multiplication of the conjugate and just write the final fraction, which part of the Peel framework did they fail? Point, evidence, explanation, or link? If you said explanation, you hit the nail on the head. They skipped the mathematical explanation and the examiner will penalize them.
This brings us to a massive psychological hurdle, applying the X plus IY form to an entirely unfamiliar scenario. Why do students freeze up? Because under the pressure of the marathon, your brain reverts to what it knows. When you see a question involving locus on an Argand diagram mixed with a complex Cartesian equation, panic sets in. The syllabus is designed this way. The examiners actively try to invent scenarios you've never seen before. They want to test if your analytical depth is strong enough to adapt. Sam rushes these questions, assumes it's a standard linear equation, completely ignores the complex plane constraints, and fails the question. You have to stop, breathe, and trust the procedural strategy. To overcome that exact hurdle of unfamiliar contexts, we need a bulletproof procedural framework. Welcome to Section 3, the methodology framework. Deconstruct, solve, evaluate. This is where we take the red pen marks on Alex and Sam's papers and transform them into green check marks. Let's dive deep into this transformation. Imagine we are doing a live rewrite of Alex's messy answer. Step 1. Deconstruct. We extract the relevant equations. We highlight the command word. If it says equate, we literally draw a line down our page. Real on the left, imaginary on the right. Step 2. Solve systematically. This is our explanation in the PEL framework. We break it into logical steps. We take that chaotic jumble of X and I terms and we systematically factor out the I. Step 3. Evaluate. This is where Sam always fails, checking reasonableness. If the question stated that X and Y are positive real numbers and your quadratic yields a negative X, you must explicitly reject the negative value and justify Y. If you don't write down, reject X equals -3 because X must be greater than 0, you lose the final accuracy mark. Just imagine a 60-second timer ticking down in the exam. This 3-step process is what keeps you grounded. And look at this checklist. Examiners will literally dock points if strict presentation conventions aren't followed. Headings must be structured. Terminology must be correct. If you mean complex conjugate, write it. Don't just say the opposite one. Formats need appropriate application, and your annotation must be clear and evident. I cannot stress this enough. Your paper needs to read like a professional mathematical proof, not a scratch pad. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Take control of your revision right now. All right, let's jump straight into our interactive workshop in Section 4, Examiner Warnings. We are going to put you on the clock. I'm going to present you with 3 challenges based on the exact mistakes highlighted in principal examiner reports. Let's start with Challenge 1, the data scan. Imagine a complex math chart on screen showing the roots of a polynomial equation in the complex plane. You have 60 seconds. What is the core trend? The trend is that complex roots of polynomials with real coefficients always occur in conjugate pairs. If you don't instantly recognize that X plus IY has a partner X minus IY, you will use the wrong approach and waste 20 minutes doing long division incorrectly. Now, Challenge 2, find the flaw. I'm going to describe a flawed paragraph. A student writes, I expanded the brackets, moved all terms to one side, and used the quadratic formula to find X. What is the massive, grade-crushing flaw here? You have 30 seconds to think about it. The flaw is that the student treated a complex equation like a standard real quadratic. You cannot use the standard quadratic formula to solve an equation that has I mixed into the coefficients without isolating the real and imaginary parts first. They forgot the fundamental format of X plus IY. They failed to equate the real parts to the real parts and the imaginary to the imaginary.
This is exactly what we mean when we say you must use the right approach for the specific context. Moving to Challenge 3, Speed Writing. You have 30 seconds to mentally draft a perfect Peel paragraph for the final step of a complex numbers question. A generic approach, which loses marks, looks like this. So x is 4 and y is 2. Bam, done. But a context-specific approach, which gets top marks, looks like this. Equating the real components yields x squared minus y squared equals 12. Equating the imaginary components yields 2xy equals 16. Solving this simultaneous system provides x equals 4 and y equals 2, which satisfies the initial quadrant constraints. Do you hear the difference? One is a guess, the other is an airtight mathematical argument. Let's let that sink in for a second. This quote is a direct principal examiner alert. The classic mistake is providing generic answers not specific to the question context. This is the ultimate warning. If your answer could apply to any generic worksheet from Year 9 mathematics, it is not good enough for an A-level or even a top-tier IGCSE paper. You must relentlessly link every single algebraic step back to the X+iy scenario sitting in front of you. This brings us to our final act, Section 5, the complex numbers blueprint. We've seen Alex overload on facts. We've seen Sam rush and miss command words. Now, let's build the final system that guarantees you don't make their mistakes. This cheat sheet right here is your progress bar to 100% mark potential. It boils down to 3 undeniable rules. Rule number 1, command word decoding. You must start by circling words like hence, show, or evaluate. Rule number 2, Peel framework application. State your point, provide your given evidence, execute your algebraic explanation, and link back to the constraints. Rule number 3, the time management matrix. Don't spend 15 minutes on a 3-mark algebra expansion, and don't rush a 7-mark evaluation question. Execute with clear notation, keep your real and imaginary parts walled off from each other, and always justify your final recommendations. If you master these core principles, apply the exact presentation formats examiners demand, and rigorously evaluate your performance, that jump from a B to an A star isn't just possible, it is a mathematical certainty. Students who implement these highly specific, structured mathematics strategies see an average improvement of 2 full grade boundaries. But, and this is a massive but, that only happens if they practice consistently with our weekly breakdown videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at Ace the Exams IGCSE, to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCS and click that bell. Don't let another exam pass you by while you are still making the same generic mistakes as Alex and Sam. So I leave you with this final provocative question. When you sit down, open that paper, and face your next complex numbers question, are you going to just blindly solve for x and y, hoping for the best? Or are you going to act like the marathon runner, pace yourself, and mathematically prove the entire analytical process step by step? Drop a comment below right now with your target grade for mathematics and tell me the biggest challenge you're currently facing. Is it time management? Is it complex algebra? Our team responds to every single comment. Like this video, share it with your study partner so you can hold each other accountable. And remember, ace the exams. Your Cambridge success starts here. Keep practicing, and I will see you in the next explainer.